So our final stop on this train here is to find the mean. And to do this, I've written out the arrest data that we used for the last couple of examples. Right, so same numbers. And what we're going to do is find the mean for this data here. As before, our n is 12 because we have 12 observations in our sample. To find the mean, we're going to use the mean formula, which is what allows us to add up the number of observations and divide by the total number of observations. So the mean formula looks like this. So x bar equals the sum of x over n. And this is the first formula that we're going to encounter that really looks like a formula. And so I'm going to walk through what each of these things mean. X bar is equal to the mean. Anytime you see an X bar in statistics, it's going to refer to a sample mean. So we're treating this as a sample. We're saying this is 12 people out of some greater population, and we're looking at the number of arrests that either one of them have. So we're going to try to find the mean for our sample, or X bar. X here refers to the different observations. So we would consider this to be an X, 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 and so on. So X is something that we'll use to refer to observations within a sample. N, as we said before, is the total number of observations in a sample. And finally, this Greek letter here is sigma, and sigma means add up whatever comes next. Or take the sum of whatever comes next. So here, we can break this equation down using each of these different definitions and find the mean for this data. So I'm going to write this out one more time. X bar is equal to the sum of your x's divided by n. Sum means add everything up. So I'm going to put parentheses here, and we're going to add all the stuff up. What we're adding up are the different x's in our sample. So in other words, we're just going to write out all the different observations that we have. You don't need to put them in any order for this one. And so we're going to take the sum of the different observations in our sample. Again, we're writing that out as all the different observations in our sample added up together. Next, we're going to divide it by the total number of observations in our sample, which we've already established is 12. So in order to find the mean, all we do is take the sum of this top row and divide it by 12. This here comes out to 18 over 12, which is 1.5. So the mean number of arrests in the sample is equal to 1.5. In other words, there's an average of 1.5. And the nice thing about the mean is that it uses all of the information that we have in the data. In other words, every observation affects what the mean turns out to be. And that's not the case for ordinal level data. So for example, if you were to switch this last one out here for a PhD, it wouldn't affect what your median is, because the only information that we're getting out of this observation is its order in the line. Whereas if you were to switch this number out for a higher number, it would change the value of your mean. There's also a way to find the mean from a frequency distribution that we're not going to talk about. And if you're wondering why I keep talking about frequency distributions, it's because I usually make you guys learn it in this class, and so my brain just keeps autopiloting to the things we can do with frequency distributions. But as I said before, it's not really a useful skill to have, so we're going to skip it. I'd rather you focus on what the mean actually means and just think about how to calculate it for smaller amounts of data.